Right. Hey, ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 6, Note 6. We're going to be talking about angles of elevation and depression. So this is Unit 6, Note 6. So let's go ahead and let's take a look at what those two things mean. So first of all, the angle of elevation of an object as seen by the observer is the angle between the horizontal and the line from the object to the observer's eye, line of sight. Now that's a lot of really confusing words. So let's just tap into Miss Humbert's artistry here and let's draw a picture. Now the rule is you can't make fun of me too much, okay? I'm going to do the best I can. So let's say we have a person here. We'll call her Betty. So there's Betty. She's sitting there. Betty loves to look at the sun, even though her mama said, no, don't look at the sun. You'll burn your eyeballs. She's still going to do it. So Betty has a horizontal line of sight. She's looking straight ahead. Well, that's not that exciting. It's not really easy to see the sun when you look straight ahead. So sometimes when you look at the sun, you have to look straight up. So this angle right here, that's called theta. Okay, we use that to represent angles. That represents the angle of elevation. So we're talking about how she's looking up at the sun. Well, the nice thing is if you go straight down here, you formed a right triangle. So to solve for angle of elevation, we can also use these SOHCAHTOA ideas that we've been using the past couple of note sheets. Now you can also use it for angles of depression. Okay, so if an object is below the line of sight of the observer, okay, then the angle between the horizontal and the observer's line of sight is still called the angle of depression. So let's say you're flying in an airplane. You're going somewhere a lot more exciting than school is. Just kidding, you love school. So look at that awesome airplane. It looks like a gingerbread man. Okay, so that's an airplane. All right, and you are looking down below at this beautiful tree. You're trying to see if there's squirrels in it, and I don't care that the tree is blue. You're just going to deal with it. Okay, so we want to find the angle of depression. So normally when pilots are flying the plane, they're looking straight. Ooh, straight, Miss Humbert. Straight ahead. Straight ahead. That's as straight as that line's going to get. Okay? But actually, if they're looking down at the tree, they're going to be looking down. And this is theta here. So this represents their line of sight. Okay, so this here, we can also look at it this way. This is also theta if you have a triangle there. Both of these here represent your angle of depression. Okay, all right, so let's go ahead and let's move forward. So let's take a look at this first word problem. Again, you judge my drawing, I'll cry. Okay, so draw a sketch to represent the problem, include the numbers, values represent the unknown, yada, yada, yada. Follow those directions, they help. Okay, so let's take a look at this first problem. So a tree casts a shadow 25 feet long. So here is my tree, it's green, because it's healthy. Okay, and it casts a shadow that's 25 feet long. So right here represents our shadow. The angle of elevation from the tip of the shadow here to the top of the tree here is going to be 64 degrees. Find the height of the tree. Well, the height of the tree is going to be represented by x. So now we're going to look at that as a right triangle, okay? So we have, here's our right angle here. So this is the hypotenuse. That doesn't help us at all. So what we have is our adjacent and our opposite. So we need to use tangent. So tangent of 64 is equal to our opposite, which is x, over our adjacent, which is 25. So now to solve for x, I'm going to have to multiply both sides by 25. So then I get that x is equal to 25 tangent of 64. 25 tangent of 64. So again, you should be really good at typing that into your calculators now. And that should give you 51.26. And we're going to say that's feet because the shadow was in feet. So the tree is 51.26 feet tall. It's a pretty tall tree. Okay, anyway, next, a jet takes off and rises at an angle of 19 degrees. So here's my jet taking off. You know what? I know you're probably internally making fun of my drawing, so I'm just going to draw it on here. So the jet's taking off. So here's the ground, and that's the jet taking off. It's taking off at 19 degrees. Okay, so then it says that until it hits an elevation of 2,000 or 28,000 feet. So this right here is 28,000 feet. How much was the ground distance covered in miles? Well, that's going to be our x down there. So what do I know about this character here? Well, I know my angle measure here, and then this is going to be opposite. My hypotenuse, this is my right angle, is here. So this right here is the opposite, and this x down here is the adjacent. You will find that with these problems, with the elevation and depression problems, you're going to find a lot of tangents. We're going to be using tangents a lot. So tangent of 19 is equal to opposite, which is 28,000, divided by adjacent. So now we have to solve this for x. So the first thing I'm going to do is multiply x by both sides. So I get x tangent of 19 is equal to, those x's cancel, to 28,000. So now to solve for x, I'm going to divide both sides by tangent of 19. So then I end up getting x is equal to 28,000 divided by tangent of 19. So that's going to give us 81,317.9 feet. Now here's the catcher. If you look at the original part of the problem, it asks us what is their initial height covered in miles, and it gives us how many feet are in a mile. So to get the number of miles, I'm going to take the number of feet and divide it by how many feet are in a mile, 5.208, and that will tell me the number of miles. So I end up getting 15.4 miles. So there's 15.4 miles covered. All right, as our final answer. Next, let's take a look at that next word problem here. So from the top of a vertical cliff, so here's my cliff right here. Okay, the vertical cliff is 40 meters high, so our cliff here is 40 meters high. The angle of depression of an object that it is level with at the base of the cliff is 34 degrees. So we're looking out into this beautiful ocean, and we just pick a spot. We maybe see a surfer right there. No, I don't want to do that. Okay, so then we're looking down to that surfer. Hey there, little guy, let's draw him. And there's his little surfboard. Yeah, okay. Anyway, so the angle at which we're looking is 34 degrees. And they want to figure out how far out into the ocean our little surfer dude is. So that's going to be our x. So what do I notice? I notice that I know my opposite. I want to know my adjacent. So again, I'm going to use tangent. So I'm going to take tangent of 34 is equal to our opposite, which is 40, over our adjacent, which is x. So now we're going to go ahead and solve this for x. So I'm going to take and I'm going to multiply this by x, and I'm going to multiply this by x. So x tangent of 34 is equal to 40. Now to solve for x, I need to divide both sides by tangent of 34. And I get that x is equal to 40 divided by tangent of 34. So again, I'm going to plug that into my calculator. And when I do that, I end up getting 59.30. And it's a word problem, so we want to label it meters. Okay, so we're talking meters for that one. Next, let's take a look at number 4. So we have a plane that's flying, and it must approach at a 5-degree or 5% angle. So we're flying downward this way. So here's the airport, the start of the runway where we're landing. Okay, so here's my right angle. The angle at which we approach has to be 5 degrees. And we start approaching that 5-degree depression when we are 182 kilometers away from the runway. So how high up are we? What's our altitude? That's going to be x. So again, in this equation, I know my opposite and I know my adjacent. So let's go ahead and use tangent again. So tangent of 5 degrees is equal to our opposite over our adjacent. So now we need to solve this for x. So to do that, I need to multiply both sides by 182. And then I get that x is equal to 182 tangent of 5. Okay, so then when you multiply that out in your calculator, you end up with 15.92. And again, we want to make sure we label that kilometers. All right, let's take a look at number 5. So for number 5, a surveyor is 100 meters from a bridge. So let's draw our little surveyor. Here's his pretty little camera that he does stuff with. Okay, then he's looking way out at a bridge. Yay, here's my bridge. Wow, that's some artwork. Okay, and then here's what we know. It says that our surveyor is 1.45 meters above the ground here. Then it says that he is 100 meters away from the bridge. So ground distance, he's 100 meters. We want to figure out how tall the bridge is. Okay, we don't actually need this 1.45 meters. That actually doesn't tell us anything. And sometimes word problems do that to try and trip you up a little bit. Okay, they give you problems you don't need. So we know that this degree is 35 degrees. Again, we know our adjacent, we want to know our opposite. So tangent of 35 is equal to our opposite over our adjacent. So now we need to solve this for x. So what I'm going to do is I'm going to multiply both sides by 100. So I'm going to get that x is equal to 100 tangent of 35 degrees. So 100 tangent of 35 degrees. Again, at this point, we're ready just to plug her into our calculator, which you should be doing along with me to make sure you get the right answers. Then we get 70.02 meters. 70.02 meters for x. Taking a look at number 6. Okay, so a search and rescue team is airlifting people from a scene of a boating accident when they observe a person in need of help. So here's our person in need of help, way down there. Okay, if the angle of depression to this other person is 42 degrees, so that's our angle getting to that person, and the helicopter is 18 feet above the ground, what is the horizontal distance? So that's where we're looking. So again, we know our opposite, we want to know our adjacent. Okay, we have to use tangent. So we're going to take tangent of 42, and we're going to set it equal to our opposite over our adjacent. So again, to start solving this, I'm going to start by multiplying both sides by x. And then I get that x tangent of 42 is equal to 18. Now to solve for x, I need to divide both sides by tangent of 42. And I end up getting x is equal to 18 divided by tangent of 42. Again, now it's ready for us to plug it into your calculator. And when we do that, we get 19.99. And we look, everything is labeled in feet. Okay, so sometimes setting these up can be hard, so definitely let me know if you have a question. That concludes your note video today. Go ahead and show me your note sheet when you're done. Thank you for listening.